Welcome back to the Deep Dive. We're diving deep today, and our source material is becoming super important for anyone involved with AI. It's the Isaac Advanced in AI Audit Official Review Manual. Now, this manual, it's really designed to give you a structured, kind of practical way to think about AI from that governance, risk, and audit angle. It's just packed with key insights.
Yeah, it really is.
And for this deep dive, we're really going to focus, we're zeroing in on Chapter 1, Part C, the main topic, AI risk management.
Crucial stuff.
Yeah, totally. We're going to unpack the unique challenges AI brings to the table and the strategies organizations really need to get a handle on identifying, assessing, and importantly, monitoring the risks that come with using these powerful AI systems.
And this is just foundational, absolutely foundational. The manual, yeah, it might be aimed at auditors, but honestly, the ideas, the processes in this section, they're essential for anyone touching AI in a company. If you're building it, using its output, managing the systems it talks to, understanding AI risk, it's just not optional anymore. So think of this as like us sitting down with you. We'll walk through this section together, almost like instructors, hitting the key points.
Exactly. This is your deep dive, tailored for you, helping you cut through the noise and find those really important nuggets in this part of the manual. We'll stick to the manual structure, building it up step by step.
Okay.
Let's get into it. Where do we even start with managing risk in this AI world?
Well, the manual kicks off right where you'd expect.
Identification.
Yep, identifying the risks, section 1.11. And it makes a key point right away. AI risks. They present challenges that often go way beyond what we're used to with, say, traditional IT systems.
Okay, so why is that? Why is AI risk identification different? More complex even?
Well, it really comes down to the nature of AI itself, doesn't it? Think about it. Traditional software, it follows rules we write, explicit instructions.
Right, deterministic.
Exactly. But a lot of AI, especially machine learning stuff, it learns from data. And that brings in a whole bunch of tricky aspects. You've got the black box problem. Sometimes it's really hard to know exactly why an AI made a certain decision. There's huge dependency on data, which has its own risks. And models can drift. Their performance changes as the data they see changes. So the source material, it really emphasizes how far these impacts can reach.
Yeah.
Yeah, they can hit individuals directly. They can totally reshape how an organization works, its reputation.
Right, the whole reputation piece.
And they even affect like whole ecosystems. It's big picture stuff. So risk identification, it's not just about finding technical bugs.
Yeah.
You need a much, much broader view. You got to consider how its decisions, its actions could cause harm in all sorts of ways, sometimes ways you didn't even expect.
That makes a lot of sense. The ripple effects just seem potentially massive, and the source, it gets really specific about who might cause these problems. Figure 1.21 talks about threat actors. This part I found really interesting.
Oh.
It's not just the stereotypical hacker in a dark room, is it?
Not at all, no. The manual breaks it down into several categories, and it makes it clear. Risk can come from inside, outside, even from the folks building the AI.
Okay, walk us through them.
Sure. First up, insider threats. These are your employees, contractors, partners, people who already have legitimate access.
Right, they're already inside the castle walls.
Precisely. And the threat can be malicious. Someone deliberately misusing an AI tool, maybe stealing data, sabotage, or it could be totally unintentional. Think about an employee just pasting confidential company info into an internal AI chatbot that wasn't built to handle it. Oops.
Yeah, I can see that happening easily.
The manual gives that exact kind of example, entering confidential data or using an internal tool for personal gain. And this is tricky because, like you said, they already have access. Your usual perimeter defenses don't really help much here.
Okay, who's next?
Then you have nation states. Now, their motivations are usually different, more strategic, geopolitical.
Right.
They might use AI internally for, say, surveillance or censorship, monitoring citizens externally. They could target other countries' AI systems, maybe for cyber espionage, stealing valuable AI models, algorithms, or the data the AI uses. Or they could launch actual disruptive attacks against critical AI infrastructure. Think power grids, finance.
Serious stuff.
Very. And they often have significant resources and expertise.
All right. What other actors?
Cyber criminals. This is probably more familiar territory, but AI changes the game for them too. They can use AI to make their existing attacks malware, phishing way more effective.
Yeah.
Harder to spot.
Like AI-powered phishing emails that are perfectly tailored.
Exactly. Or malware specifically designed to mess with AI models, adversarial attacks, that kind of thing. Their main driver. Usually money. Ransomware hitting AI-dependent businesses, stealing data. complex fraud schemes.
Okay, makes sense. Any others?
Yes, and this one is sort of unique to AI
It's
developer.
people building it. How are they a threat actor?
Well, it's not always about malicious intent, although that's possible. The risk here often comes from the sheer complexity of building these systems. Developers might, maybe unintentionally, or maybe due to pressure or lack of oversight, create AI solutions that just don't align with ethical standards. Or maybe they miss certain regulatory requirements.
So like building bias into the system without realizing it.
Precisely, leading to unfair or discriminatory outcomes.
Uh-huh.
Or maybe they design a system that's vulnerable to being manipulated, or it could just have flaws that lead to unexpected failures, like denial of service. The risk comes from the difficulty of creating these complex systems perfectly robust, fair, secure, right from the get-go.
Wow, okay. So the threat landscape is much, much wider than I think many people realize. It goes from external state actors right down to potential, maybe even accidental issues from the internal development team.
Exactly. And connecting these actors, like Figure 1.21 does, to potential scenarios really makes it concrete. You can picture a nation-state using AI for surveillance or a cybercriminal deploying that AI-enhanced malware.
Yeah, definitely. Okay, so identifying who might cause a problem is step one. But then there's the what. What kind of problem, what kind of harm are we talking about? Figure 1.22 in the manual breaks this down. What jumped out at you there?
That figure is incredibly useful because it outlines 3 broad categories of harm. It really shows how AI's impact can spread. The first category, and maybe the most sensitive, is harm to people.
Right.
And this covers a lot. There's physical or psychological harm. Think an autonomous vehicle causing an accident that's physical, or the stress from constant algorithmic surveillance, psychological. Then there's violation of safety or economics. Maybe AI leads to unsafe working conditions, or biased algorithms denying loans, or rejecting job applications, causing real financial harm.
Okay.
And critically, there's loss of rights, discrimination, or lack of participation in society. This is huge. AI systems can unfortunately pick up and even amplify existing societal biases. This could lead to unfairness in hiring, the justice system, education, access to basic services, effectively locking people out.
That's a heavy responsibility for these systems.
Right.
What's the next category?
The second is harm to an organization. This feels more like traditional business risk, but AI can crank up the volume, you know?
How so?
Well, you've got obvious things like financial losses, AI errors leading to bad investments maybe, or successful cyber attacks on AI assets, or even just fines for not complying with AI regulations.
Sure.
Reputational damage is massive. If your AI is seen as biased or unreliable, public trust can just evaporate overnight. Brands can be seriously damaged. Operational disruption. Imagine if your supply chain AI or your customer service AI goes down or gets compromised. Operations could grind to a halt.
Yeah, critical dependency.
And given how data-hungry AI is, loss of intellectual property, your training data, your unique models, that's a major threat. Plus supply chain issues if AI-driven logistics fail.
Okay, that makes sense. And the third category?
The third is harm to an ecosystem. This is the broadest one, looking beyond just the immediate organization or user.
Like environmental impact?
Exactly. Environmental harm is one example. Maybe poorly optimized AI in manufacturing leads to more pollution, or it could affect the global financial system or supply chain. Imagine if widely used interconnected AI systems in finance had cascading failures,
Yeah.
or were manipulated simultaneously. And it could even impact natural resources, think AI in agriculture or water management having unforeseen negative ecological effects. This category really forces you to take that macro view.
That's quite a spectrum of potential harm, from individual rights to global ecosystems. It really drives home why just saying AI risk isn't specific enough. You need to think about who could cause it and what the specific consequences might look like.
Absolutely. You can't manage risks you haven't properly conceptualized. Understanding the who and the what is the essential foundation.
And to help prioritize all this, the manual brings in the idea of risk levels, referencing those EU AI Act categories in Figure 1.24. How does that framework help?
It's super helpful. The EU AI Act's approach, which the manual shows visually like a pyramid, gives us a widely recognized way to classify AI systems based on how risky they potentially are. And that, in turn, dictates how much scrutiny and risk management rigor is needed.
Okay, so what are the levels?
At the very peak, the smallest group but highest risk is unacceptable risk. The EU Act defines this as stuff that's a clear threat to fundamental rights. Think government-run social scoring systems.
Right, those are generally banned.
Exactly. They're considered too dangerous to democratic values, so they're typically prohibited.
Okay, what's below that?
Next level down is high risk. These systems are allowed, but they come with really strict rules. Mandatory risk management, data governance, technical checks, human oversight, conformity assessments before they go live, ongoing monitoring, the works.
And what kind of systems fall into this category?
We're talking about AI in critical areas. Law enforcement, like predicting crime hotspots or evaluating evidence. Managing critical infrastructure, water, power grids. Education, deciding who gets into university. Employment screening resumes, evaluating performance. Safety components in products, think AI in medical devices or self-driving car systems. The potential for harm is significant, but the benefits are seen as worthwhile if, and it's a big if, those strong safeguards are in place.
Got it. High risk, high requirements. What's next?
Below high risk is limited risk. For these AI systems, the main obligation is usually transparency. Users need to know they're dealing with an AI.
Like chatbots.
Chatbots are the classic example. They might give wrong answers or be annoying, sure, but the overall risk is generally seen as lower than, say, an AI diagnosing medical conditions. The key is making sure people aren't tricked into thinking they're talking to a human if they're not.
Makes sense. And the bottom level.
At the base of the pyramid, the biggest category is minimal risk. This is most of the AI we interact with daily. Spam filters in your email, AI opponents in video games, simple recommendation engines.
Okay.
These are seen as having negligible or basically no risk to people or society. So under the EU Act, they're largely unregulated, though general good practice still applies, of course. This whole framework is invaluable because it tells an organization, okay, for this AI system, here's the level of effort and compliance you need to be thinking about. It's definitely not one size fits all.
That clarity is really needed. And, the manual briefly touches on this in 1.1, 1.3. One of the big challenges is that AI risk management as a field, it's still kind of immature. It's not consistently understood or applied everywhere.
That's a really important point.
Yeah, and that lack of maturity really underscores why the next steps we need to talk about assessment and monitoring are so incredibly vital. Just identifying the risks. That's only the starting line.
Couldn't agree more.
Okay, so we've mapped out the potential threats, the kinds of harm, the risk levels. We've identified what could go wrong. What's the next logical step according to the manual? How do we actually assess how bad these risks might be for us specifically?
Right, that takes us squarely into section 1.0, AI risk assessment. And the manual emphasizes something fundamental right away. AI risk assessment isn't a separate techie thing you do in a corner. It has to be plugged into your organization's main enterprise risk management, or ERM, framework.
So treat it like any other major business risk.
Exactly, because that's what it is. It has business impacts. Another key point is that risk changes throughout the AI's life. The risks when you're just gathering data are different from when you're training the model or when it's live and running or being updated. So the assessment has to look at the whole life cycle.
Okay, so what are the key steps in doing this assessment according to section 1.12?
Well, first, there's the core AI risk assessment activity itself, 1.1.1. This isn't just making a list. It's a systematic process to identify and analyze the risks. Analysis means figuring out, okay, how likely is this bad thing to happen? And if it does happen, how bad will the impact be?
And you mentioned the ecosystem.
Yes, you have to look beyond just the AI model. What about the data feeding it, the servers it runs on, the other apps it connects to, the people using it? It's the whole picture. And a big challenge here, honestly, is getting the right people talking to each other. You need the AI tech experts, the risk managers, compliance folks, legal, auditors.
And they don't always speak the same language.
Precisely. They might have different perspectives, different expertise levels in each other's areas, but you need that combined view for a proper assessment.
Okay, what else is crucial for assessment?
Second key element, understanding the organization's risk tolerance. That's section 1.1.2. Basically, how much risk and what type of risk is the organization actually willing to stomach while trying to achieve its goals?
So setting the boundaries.
Exactly. This needs to come from the top, from leadership, and everyone needs to understand it. It becomes your benchmark. If you assess a risk and it's above your tolerance level, you have to do something about it. If it's below, maybe you can accept it. Without that clear tolerance level, decisions about risk can get really inconsistent, very subjective.
Right, you need that yardstick. What's the third piece?
Third, based on that analysis of likelihood and impact, you get to risk response and prioritization. That's 1.11.3. Look, no organization has infinite resources. You can't fix every single potential risk all at once.
Sure.
So you have to prioritize. You rank the risks based on agreed criteria, usually how severe the impact could be, combined with how likely it is. And that prioritization directly informs which risks you tackle first and how you choose to respond to them.
Okay, that leads perfectly into the response itself. Once you've assessed and prioritized a risk, what are the actual options? What does Section 1.12.4 say about how organizations can respond?
Yeah, the manual outlines the standard risk response strategies, which apply just as much to AI risks as any other kind. There are basically four main choices. First, and often the most proactive one, is mitigate,
Meaning?
meaning you take specific actions to make the risk less likely to happen or to reduce the damage if it does happen. This is where controls come in.
Right.
Technical controls, maybe better cybersecurity, stricter data checks, maybe choosing AI models that are easier to explain, and procedural controls, updating policies, having really rigorous testing, training people properly. So, for example, if your risk is bias in a hiring AI, mitigation could be things like monitoring fairness metrics, using really diverse training data, and making sure a human reviews the important decisions.
Got it. Reduce the risk. What's option two?
Second option is transfer. Here, you're essentially shifting the financial or operational fallout of the risk onto someone else.
Like insurance.
Insurance is a prime example, yeah. Getting a policy that covers specific cyber or AI failures. Or it could be through contracts with your vendors or partners, clearly stating who is responsible for managing which risks. Cloud providers are a common case here with shared responsibility models. You handle some risks, they handle others related to the infrastructure. The risk isn't gone, but the burden of paying for it or dealing with the immediate consequence is moved.
Okay, mitigate or transfer. What else?
Third option is accept. Now, this is important. It's a deliberate decision to not take specific action right now.
So not just ignoring it.
Absolutely not. It has to be a conscious, informed choice. You document it, and it's usually based on your risk tolerance. Maybe the risk level is below your threshold. Maybe the cost to mitigate or transfer is just way too high compared to the potential damage. Or maybe the risk is just inherent in doing business and you can't get rid of it without stopping the activity altogether. The key is, it's a reasoned decision, usually signed off by the risk owner or management.
Okay, that makes sense. Mitigate, transfer, accept. Is there a fourth? Wait, I might be thinking of avoid.
Well, avoid is sometimes listed as a fifth strategy, deciding not to proceed with the activity causing the risk at all. But the manual here focuses on mitigate, transfer, and accept as the primary responses once an activity is underway or planned.
Gotcha. And the manual specifically mentions remediation plans in this section, point of 4. That seems really important for the risks you don't just accept, right? The ones you decide to mitigate or transfer.
Exactly. For any risk you've decided needs action, you absolutely need a clear, actionable remediation plan. What does that look like? Well, it spells out the specific steps needed. It assigns responsibility to a named risk owner, someone who's accountable for getting it done, and it sets deadlines, expected completion dates.
Having that named owner seems critical.
It is. They're the ones who have to drive the implementation of the controls or actions in the plan and make sure the risk actually gets reduced to an acceptable level. These plans aren't just documents to file away. They need active management, tracking, which leads us very nicely into the final piece of this chapter.
Monitoring.
Right.
It really paints risk management as this continuous cycle, not just a one-off check. Assessment informs the plan, and the plan needs to be monitored.
Precisely. It feeds directly into operational reality.
Okay, so let's talk about that ongoing part. We've identified the risks, assessed them, got plans in place. But AI isn't static. The world isn't static. How do we make sure our defenses stay effective and catch new problems? This brings us to section 1.13, AI risk monitoring. Why is this continuous part so vital for AI?
Yeah, AI risk monitoring, as Section 1.13 defines it, is that ongoing process. You're watching the risks you already know about, sure, but maybe even more importantly, you're also scanning for and responding to emerging risks, things you didn't anticipate initially.
Because things change.
Constantly. AI models can drift. Their performance degrades as the real-world data they see changes from their training data. The threat landscape shifts, hackers come up with new tricks, new adversarial attacks, user behavior changes, regulations change. If you're not continuously monitoring, even the best controls you put in place can slowly become useless. A risk you thought was minor could suddenly blow up.
So monitoring keeps the risk management process alive and relevant.
Exactly. It's the feedback loop. And the manual explicitly links it in 1.13.1 to ensuring continuous improvement. The insights you get from monitoring, they should drive updates. They should refine your risk strategies. It's not static, it's adaptive.
Okay, makes sense. But how do organizations actually do this monitoring day to day? What are they looking at?
Right.
The source talks about performance indicators, PIs,
Yeah.
and key risk indicators, KRIs, in 1.13.2. Can you unpack those?
Sure. Think of it this way. Performance indicators, or PIs, generally measure how well something is doing its job. Is it meeting its objectives? For an AI, a PI might be its accuracy rate or how fast it processes things. It's about overall performance or health.
Okay, basic performance metrics.
Right. Now, key risk indicators, or KRIs, are different. They are specific metrics chosen because they act like early warning signals. They're designed to flash red before a risk event actually happens, or maybe indicate that a control isn't working anymore.
So they're more predictive.
Ideally, yes, proactive. KRIs are usually tied to specific thresholds. If the KRI crosses that threshold goes too high or too low, it triggers an alert. Someone needs to investigate, maybe take action. So PIs tell you how things are going. KRIs warn you if things might be about to go wrong.
That's a really helpful distinction. PIs are about performance, KRIs are about potential trouble. The manual gives that chatbot example in Figure 1.25. Can we walk through some of those KRIs to make it really concrete?
Absolutely. Figure 1.25 is great for practical examples. For a customer service chatbot, they suggest tracking things like first, customer satisfaction score. Maybe you set a target, like 95% satisfaction or higher. If that score starts to dip, that's a KRI flashing. It could signal various risks, the bots being unhelpful, frustrating users,
Right.
potential reputation damage. Right.
Yeah, okay. What else?
Resolution rate. Let's say the target is 90% or more. This measures how often the chatbot solves the user's problem without needing a human. If this rate drops, maybe the bot isn't keeping up with new types of questions, maybe the model is drifting, it signals declining effectiveness, potential operational issues. Then there's misunderstanding rate. You want this super low, maybe less than 1%. How often does the bot just completely misinterpret the user or give a nonsensical answer? If this starts creeping up, it's a direct warning about accuracy risk. Giving wrong info could have real consequences.
Definitely.
And finally, escalation rate. Also want this low, maybe under 10%. How often do conversations have to get bumped up to a human agent because the bot failed? A rising escalation rate tells you the bot isn't meeting user needs effectively. Could be issues with its training, its scope, leads to inefficiency, bad user experience.
Okay, those are really clear examples. You can see how tracking those numbers gives you real-time insight into specific potential risks associated with that chatbot.
Exactly. They turn abstract risks like inaccuracy or user frustration into things you can actually measure and set alerts for.
The manual also brings up another framework for thinking about drivers, the SAFE framework, in Figure 1.26. This seems geared more towards developed AI solutions. What's SAFE about?
Right. The SAFE framework is another really useful structure. It focuses on 4 crucial attributes for trustworthy AI, and you can build KRIs around each of them. SAFE stands for S is for sustainability. This is about the AI being robust, reliable, stable over time.
Yeah.
Can it handle weird inputs? Is it resilient to manipulation? KRIs here might track things like system uptime, error rates when it's under load, or how well it resists known adversarial techniques.
Okay, robustness. What's A?
A is for accuracy. This is the fundamental technical quality. How correct are the AI's predictions or outputs? Does it match reality? KRIs for accuracy are often standard machine learning metrics. Error rates, precision, recall, maybe AUC scores, depending on the task. You track how well it performs against the ground truth.
Got it. F.
F is for fairness. This is huge, ethically and often legally. Is the AI producing equitable outcomes for different groups of people? Or is it discriminating based on things like race, gender, age? KIs for fairness involve specific metrics designed to detect bias, things like demographic parity, equalized odds ratios. You compare outcomes across groups.
Crucial. And E.
E is for explainability. How well can we understand why the AI made a particular decision? Can humans interpret its reasoning? This is vital for trust, for debugging, and for meeting transparency rules, especially in high-stakes areas. KIs for explainability are a bit trickier to quantify, but might involve tracking model complexity, how stable explanations are, maybe user ratings of explanation clarity.
Sustainability, accuracy, fairness, explainability, safe. That's a great mental checklist for monitoring key aspects of AI quality and risk.
It really is. And as Figure 1.27 points out, there are specific technical tests and metrics associated with each of these t-tests for robustness, RMSE or OROC for accuracy, disparate impact stats for fairness, etc. SAFE gives you the categories, and then you pick the right technical KRIs within those categories for your specific AI system.
So effective monitoring isn't just watching one number. It's about defining a sensible set of these indicators, maybe
Mhm.
operational ones like customer satisfaction, maybe technical ones from SAFE, and then having the systems and processes to track them continuously, flag deviations, and get that information to the right people.
That's it, exactly. And all this data coming out of the monitoring, the PIs and KRIs, that's the essential fuel for the continuous improvement loop we mentioned,
Yeah.
section 1.13.1.
How does that work?
Well, the monitoring data shows you where performance might be slipping or where risks seem to be growing. That tells you where you might need to update your mitigation efforts. Maybe a control isn't working as well as you thought. You adjust it. It tells you if your remediation plans are on track or if they need more attention. And super importantly, anytime there is an incident, even a small one caught by monitoring, the lessons learned from investigating and fixing it, those should feed directly back into refining how you identify and assess risks in the first place. It makes the whole system smarter over time. It's a cycle. Observe, learn, adapt, repeat.
Wow. Okay. We've really covered a lot of ground there from Chapter 1, Part C. It's quite a journey. We started with identifying those unique AI risks, the actors, the different kinds of harm to people, organizations, even ecosystems.
Hmm.
Then we moved into assessing them likelihood, impact, integrating it with ERM, considering risk tolerance and deciding how to respond, mitigate, transfer, or accept with solid remediation plans. And finally, closing that loop with continuous monitoring, using PIs and KRIs, maybe guided by frameworks like SAFE, to constantly watch performance and risk, feeding that back into making everything better.
It really provides a solid, structured approach. And the core message, I think, is that managing AI risk, it's not a project you finish. It's an ongoing capability you have to build into how the organization operates. It needs that cross-functional collaboration, tech, risk, business, and it relies on having the right data, the right metrics, the right processes to stay on top of it. This section really lays that essential groundwork.
Absolutely. And thinking about it, all the sheer range of potential harm, the sometimes surprising threat actors like developers, the constant evolution of the tech itself, it does feel like a massive challenge. But having structures like the EU AI Act risk levels or the SAFE framework for monitoring, it helps. It brings some order to the chaos and gives organizations tangible steps they can take.
It does provide that necessary structure. And, as you're thinking about all this, identifying, assessing, monitoring these constantly changing risks, maybe here's a final thought to chew on. AI technology is advancing incredibly fast. Capabilities are emerging that we didn't even anticipate a year or two ago.
It's true.
So how can organizations build risk management processes that aren't just reacting to today's threats, but are actually flexible and forward-looking enough to handle the risks of AI capabilities that haven't even fully materialized yet? What kind of proactive foresight, what kind of adaptability do we need to build into these systems to keep pace, not just with known unknowns, but potential unknown unknowns?
That is a heavy question.
Yeah.
How do you manage the risks of something you can't fully predict yet? Definitely something for everyone involved in AI to grapple with. Thank you for walking us through all that.
My pleasure.
And thank you for joining us on this deep dive into AI risk management from the AAIA Annual. We hope breaking down Chapter 1, Part C like this has been helpful. As always, we encourage you to check out the source material itself for even more detail.